Hi everyone, this is Kobe from eBay. I'm pleased to get the chance for sharing what we have done in eBay marketing. And thanks for joining this talk. I wish you and your family healthy and safe in this special period. The slides are drafted in February for Beam meetup, and I did later updates recently. So I would talk a little bit more per slide with my own understanding. I see the value for the companies like eBay, how we could benefit from combining different solutions from open source community and being inspired by the public cloud provider. Also, the experiments when push them to production. I hope it will give you more confidence to leverage Apache Beam in production. Here, Beyond Lambda reflects the Beam strengths for unifying syntax and definition for batch and streaming processes. And in reality, we can't avoid Lambda architecture sometimes, which are introduced by different infrastructure, platform, and optimizations. Then how we could figure out a way to use Apache Beam for being close to the final approach. Then we could say Beyond Lambda. So today's agenda is simple. I will give introduction from my own experiments, how Apache Beam inspired me, and why we choose Apache Beam, what the challenges, and how we resolve them, what use cases, and our next step. I will try to answer all your questions. Recently, several years, eBay offered lots of efforts for AI platform and build the AI ecosystem for driving business. You would see the enrichments for different domains. Check the link below how eBay transformed to a modern AI platform. Although we don't have much time, I still want to share the insight from my own experiments, how things to leverage, how things to change to use Apache Beam naturally, and how Apache Beam answer my questions of my previous projects. After web development for many years, I got the chance for building distributed cross system. And one important goal is less bandwidth, more cross content for that period. These things will change to the design of storing large chunks of unstructured web page content, continuous writing and appending, using any data load as cross node to reduce the cost for data movement. So the design are literally become to file system design of storing large chunks of data, how to distribute processing, and a quick lookup from big dictionary. I really realized why Google could come up GFS, big table, and MapReduce first as the biggest crawling system in the world. If you think about use Apache Beam or Spark for the crawling system, you would have a higher degree control for your page ranking, feed policy, crawl policy, etc., instead of being restricted by the disk I/O limitation from MapReduce model, right? As that time, eBay leveraged HBase for index building in their search engine. Luckily, I joined eBay and get the chance to do eBay's behavior projects for user click stream. The two main parts are sessionization and bot detection, which are related to eventing actually. And we don't have a middleware such system until 2012. So we defined the mini batch and the daily batch for marking session closed from the new events and the left open sessions in previous batches, and do the bot detection for individual session and cross sessions with rolling window pattern. So you would say, if the process SDK provides the syntax support for session window, sliding window, and the eventing trigger, even the batch job codes could be simple and clean for dozens of bot rooms and complex sessionization. Then I step into streaming world as I'm thinking of how to design the behavior project above in real time by leveraging open source from Industrial. And I noticed the currently streaming model from open source cannot help me for sessionization and bot detection with the constraints of memory and delay handling. Also, I felt very inconvenient for querying Kafka topics by writing code. So I used Carset Arca Stream for sampling streaming topics before writing any consumer codes, and I called it interactive query, which inspired new direction in the team for streaming SQL. And one of our teammates proposed Beam SQL to Google later. Meanwhile, I was busy on leveraging Spark batch capability for our next generation analytics platform in Hadoop, and deep dive on batch side optimization like bucketing join, push-down filtering, dynamic allocation, etc. This explains why Blink, which merges with Flink later, has its own batch task manager. After doing ETL work for many years, I joined the marketing organization for helping scientists feature development and model serving. That needs to cooperate with online and offline systems both. I felt it's a time to leverage Apache Beam now. So why Apache Beam? We have Storm, Lambda, Flink, Spark, many other processing framework. But from my own point of view, the Millwheel and the Streaming 101 paper are first trying to unify the syntax for the abstraction and have the whole definition to set the standards. If we say Storm defines Lambda, Lambda raise the campaign, then Beam is trying to redefine and complement streaming system by including batch as well. I would not say it's a philosophy how we look at the real world. Also, the pipeline portable helps potential change at infrastructure and platform side. In reality, the company has different infrastructure, platform, and migration plan. How we reduce the effort for integration and migration. Although different runners may still require adjustment or deep dive for the integration and tuning, but the POC could be simple for functional parts. Also, the unified model helps you to decouple the business logic with specific transformation for different runners, especially in the age of public cloud. The event-based processing model largely helps delay event handling and tracking. We are highly rely on watermark for data recovery, latency track, system capability evaluation, etc. We are inspired by the capability from different trigger combinations. Multi-language support is very needed in currently programming world. Nowadays, scientists can use Python, R, Scala, and others to do data exploration and training in notebook or from other clients. We should not add constraints on them. This is another advantage for language portability in Apache Beam. Integrate with TensorFlow extension is showing the ambition for leveraging Apache Beam in entire machine learning lifecycle for the pipeline. It also consolidates in the deployment and reduce the tracking efforts for every piece of code. And I think we will see the power in next session. Then I will go through each part with the eBay currently environment for the challenges and the solutions. So what's the challenges we meet? First, streaming development requires you have concept for the extension like window, watermark, and the trigger. Also like some advanced stateful processing. And also, if you know more built-in transformations, your work will be easier. But one key point must be specifying the coder with output schema for serialization and deserialization among different transformations. If you have own defined data objects or complex types instead of being provided ones, Apache Beam is hard to do type inferring for the correct coder, and you have to specify it. The second one is a complex structure support, like a nested structure and blob from data source or during processing, either introduced by different data publisher or security concern. Even batch processing, like Spark, you have to write a custom UDF for listed structure sometimes, but in streaming, they are more tricky, and I will talk it later. Definitely different data models are existed in any big companies since the infrastructure iteratively upgrade and adopt modern frameworks. That's major reason why Lambda fits for most of user scenarios, even build a generic query layer and maintain different pipelines for data consistency are another big challenge. Most cases allow duplicates because our target system have a good way to dedupe the records, but low data loss, and some require exact ones. So checkpoint is needed, and we can't avoid tuning for state management, even from application side. When integrates with internal components, we need to handle authentication if a customized version of open source, and also the metadata from different places. Also, there are still some gaps from streaming feature to runtime feature for model serving. Even we could have feature selection layer to retrieve and join multiple features, or provide a generic query layer or container for creating new feature from existing ones without a pipeline in pre-process before calling the model. But how to decide which part could be calculated in streaming time instead of serving time? Then we could reduce the serving latency as more as possible if we could push more to streaming side. For example, recommendation for advertisement, which is very time sensitive. So let's go back to eBay currently platforms and the infrastructure that I simplified based on my own understanding. We could see eBay is in the transmit stage, and we have to ask capacities from different platforms as resource is not collocated. Also, we need to write different codes for serving online and offline use cases. Even pipelines are similar. And more pay points are introduced by different data models in online and offline behind the ETL and the different data sources. That's why one reason we chose Apache Beam for batch and the streaming jobs at the beginning by considering portability and the strengths of system integration. And talk with model serving for unified feature layer as well. And if you compare Apache Beam with the earlier process framework like Cascading or Apache Storm, you would find they are not providing so many tabs and sticks, which would help you to save efforts for system integration. Also, the unified syntax and the reachable functions help batch job abstraction. If we compare MapReduce with Spark, the MapReduce already covered the semantic for distributed processing by local and network computation with shuffling. But Spark gives more fine-grained level control with reachable function and generic DAG management, same like Apache Beam for streaming systems with more definition and extension like triggers, watermark, and stateful function. Then about different data models, we can't leverage same pipeline codes for different data in online and offline. For example, we have streaming item topic, and we have Hadoop item tables, which are shifted by ETL process from row-based to column-based with other enrichment. So they may have different data models. So if we have streaming pipeline to generate the item feature and publish it to online and offline both, then our scientists could combine it with batch item and user tables to enrich the feature for training. They even could upload it back to online for being together with the generated online item feature for model serving. Since we publish same streaming features to online and offline with different formats like a proto buffer and a packet, but same data structure, we could have same feature selection policy and service for training and serving. So how the data flow looks like right now? I simplified the diagram, but it's still a little bit complex. Let's focus on the right and left side first. That's our own situation. We have DB replay log for transactional data and the tracking of production service for user behavior and application logs. Both of them flash into Kafka topics. And we have Apache Beam pipeline built by our feature SDK for publish features to Hadoop and Couchbase both, then serving online model execution. Also, we have GreenNice, which contains large amount of ETL processes by Spark, Have, MapReduce, and others for serving analytics and model training before. And they may or may not use the same data source as Apache Beam. If we want to have same codes for historical feature generation in the platform, all those batch jobs should use Apache Beam as well. And we know its ideal situation like the right side. So first, we could have .NET to use our feature serving in offline for model training purpose as well, which could use other features, no matter they are generated by Apache Beam or not. And also, we already provided a strong feature publisher to upload batch and all historical features to online for model serving, together with our online streaming features if needed. As you see, the feature kit contains SDK, publisher, and serving, and I will talk about SDK mainly later. So here, feature publisher have schema inferring, auto-registration, and the query capability to aggregate and publish offline feature to online if needed. And we have a metadata and feature selection policy for feature serving at the right time. Then back to the right side, we could say first is trying to hold the entire life cycle from feature registration, feature generation, and serving in the notebook. And all features are generated by the same pipeline from Apache Beam. This is ideal way for beyond Lambda. And the left side of our situation is likely in the transmit stage for powering Lambda and the switch to beyond Lambda iteratively. Also, I want to mention previous flow just 1 year before are totally different when I started it. And I haven't expected currently flow is so closing too fast until I write the slides for sharing. But I guess many companies are similar situation. After filling the gap for different data models from data flow perspective, let's back to Beam itself for our feature SDK. Regarding coder auto-generation and among transformations, since our data source are almost coming from Kafka with Aron format, we could come up the coder auto-generation for Aron based on different transformations. But we can't benefit from Beam's own type inferring based on Beam schema. Also, we noticed the Beam schema definition is more generic. So we convert our schema to Beam schema, generic record to Beam rows implicitly in our SDK. As we could define output schema, we could have a coder easily. So schema-based transformation are needed. If you use the Apache Beam earlier, you would notice more and more transformations are ended into schema package in Beam's SDK, like select, cast, rename, etc. And we did a similar stuff before, actually, by considering listed structure support implicitly. Although SQL largely lower the bar for coding transformation with a declarative way and resolve the coder issue automatically with output definition, but streaming development for feature is another story compared with ETL. Many UDF and extensions are needed, like a custom watermark, have an external call with the application token as the side input, and a complex machine learning algorithm for feature generation, etc. Also, when I joined the marketing, I compare scientist codes with ETL, our Spark ETL codes, batch codes, and found it would better to support them in a mixed way, like a Spark data frame abstraction. So what's built in we add for schema-based transformation? First, we could provide more methods for user to get output schema from existing one. For example, we have item message which contain 128 columns, but the user just want 20 columns. So they just need to filter them out. And also if they want 100 columns, they just need to remove additional 28 columns and then cast some field for their required type or union with other schema. Setting schema is associating with the field. You could apply those methods on listed field as well. The same method ended in Beam rows too, and both of them serve corresponding transformations. And finally, we could have different simple methods for P collection to help user for converting complex row to another structure. Then how it look like? Let's see one simple example here to get a valid count of user activity for the item from the streaming topic, which contains user and multiple activities in one message. First, we could directly get a corresponding collection for representing this topic message. And here the flatten is a little bit different with Beam's one, which is used for flattening listed activity to get multiple rows with the upper level user information together. You may have questions that we already support a nested structure. Could we directly use Slack with flatten? And then the answer is yes, by containing parent field like user activity.item ID. And the data structure will be a little bit different since all children will be grouped as array with user together. Then you still need to unnest the array for expanding them. So at that time, we defined several ON operators like select, where, to Arrow, to Hadoop, distinct count, and enrich cast, group by, window, etc. Since it's P collection from Beam itself, surely you could and apply for your own transformation and the Beam cycle as well. Why we have methods directly in collection instead of using Beam in apply method? Because the user could easily load or provided functions for currently collection. Surely user could use them in apply method too. By the way, you would see the distinct count with group by, which requires Apache Beam to store all values in memory for distinct and count. This actually is increase the checkpoint workload and the not good for memory utilization. And so the first thing you could see, we can divide the epoch by the window nonce and store the remainder only to reduce the memory used. But more generic, you could consider like a Bloom filter with sum for the incremental combiner if you leverage a combiner interface from Apache Beam. And even more, you could leverage stateful processing for fine-grained control and optimization. And even think about use hyperlog log from the Zeta sketch to implement it. I think later Beam already leveraged it. Then at the beginning, we have print method for pipeline to check the schema change. One thing you could find in to Hadoop, the field value of 10 slot will be used as partition and removed from output row for keeping consistency with have and Spark table definition. And then I noticed if we have interactive way to develop a streaming job in notebook in future, we don't need to do that since developer could check a collection schema by themselves step by step. Then how we consider listed structure support. Nowadays, we have formats like ARON, Parquet, ORC, port buffer, which supports nested structure well for online and offline both. Also, different teams would publish their aggregated collection for downstream. We can't avoid a corresponding transformation. And sometimes it's a kind of a waste to flatten and regroup by for the aggregated data set, because maybe you just need to want to retrieve the metrics belongs to that one collection or one single row, especially. And we could have a selector like XPath or CSS for path accessor and the generator for Beam schema, like user.user ID or user ID with the index, or just a user ID for all of them. And in ETL process, usually we use the source target mapping. So we could have a field selector and Lambda for the new field value to associate with the field builder. Then we consider the same way for predict, append, and other functions for listed structure support. And I noticed Beam did similar stuff in later version. That's why Beam put those transformations in schema package, I guess. We also meet some side effects like a type projection when we do schema-based transformation, especially for list structure. We need to reconstruct schema and row accordingly, like select single element from array of row. It could be changed to array of long. But when it comes to 2 or more elements from same array of row, it's keeping the same type. And all of them should be transparent to our users. Here are some simple examples. Sometimes you want a custom watermark, and sometimes you want to apply machine learning algorithm for the below price propensity feature, and also you want to call model for this feature generation in a streaming way. Even you can have a dashboard for input and output watermark to know current stage latency for the heavy calculation. Once we could have more and more combined functions for our user, their codes could be simple and clean. After going through all main parts of our feature SDK, how we integrate with the internal components in eBay. eBay has an internal streaming platform based on Kafka and Flink. In the earlier version, we meet several issues, like a Flink translator should leverage pipeline option from the context. Surely, right now, the Apache Beam already fixed those issues. And the different versions at the infrastructure side, like RuxDB and Hadoop. Also, different meaning for process 10 trigger between Apache Beam and Flink. And I'm a little bit concerned when Alibaba acquired Flink backer and start to prepare the Flink SDK. Then I found that they are working very closely after checking their roadmap. And our streaming infrastructure provides very good dashboard for us to check the cluster usage. You could say we can see the traffic and check the CPU and GC status, and also how many task manager used, how many slots, and also other infrastructure level information. Also the application status, and you would find the dips and the spikes and then back to normal soon. And the watermark does not a little bit impact, but not too much. You will see we have very stable input watermark. Yeah, it means our upstream does not have any latency. Yeah. And then for Kafka and Couchbase, it's easy for us to integrate with Kafka because Beam already provides the Kafka I/O with the schema wireless deserializer. So when data source have additional columns, our pipeline will refresh Beam schema accordingly. Then you would notice that we have a feature and a feature set under the same key with 10 slots but different formats. JSON is used for streaming feed to leverage subdoc as index for upsert. And the binary is a feature set for batch. So feature selection could determine which one is enough or should combine both of them. And why Couchbase? Because the eBay infrastructure officially support Couchbase well for our online service. So we use it as a feature store for our model serving with low latency. And at the beginning, we want to try Redis like first, as it supports different data structure in memory. Also, we want to try HBase or TiKV for 10 servers features. Even we want to store category features in search store for different classifications. And to be honest, I think we should not limit it by the infrastructure as an application service provider and provide a common feature serving layer. Our metadata could map a feature to different data store. One feature payload is large, then just put the feature key in the memory, like a Couchbase for faster retrieval. When feature type is fine-grained level for 10 servers, then put them in HBase for range query or subkey query. When some features are related to the item description or keyword, we could map to search index. Then those features could all be organized together for supporting kinds of search belongs to that types of feature. Then how about the integration with Hadoop? We tried different solutions for Hadoop authentication by changing Flink or Apache Beam. Not like Flink solution, Beam solution could support different Hadoop batch account in the same cluster. As our infrastructure has not integrated with Hadoop yet, that's why we started from our own Flink cluster for those solutions evaluation. Then we provide different file naming and partition function based on the record value. So normally our data will be partitioned by event window. Or here, one thing I should say, you will in just the sample I just showed in previous slides. When we publish to Hadoop, you will see we have the function to Avron first, because we leverage Apache Beam Hadoop I/O and require us to give the Avron schema. But that's the reason we could I could say the partition function could based on the generic or record value. Yeah. And we tried Catalogue, but it does also normally our data will be partitioned by eventing window. In such way, downstream could query the data based on the 10 bucket in Hadoop, or schedule new job based on new batch job based on maximum 10 slot of last batch job. In case they can consume the complete data set. Yeah. And we tried the Catalogue, but it doesn't support dynamic partition. And want to have data like I/O, but we don't want to construct a transaction node by ourselves, especially any potential format change in future at the data lake side. We can't avoid small files since we leverage file I/O if user want to publish the data with very low latency in Hadoop. So we provide generic tools for file compaction and partition editor to include the latest updates in the table. And because we use the file I/O and only could replace and open the files in HDFS, we have to deal with the side effect, which is introduced by the delay events when job reconsume from the save point. This part is a little bit complex, and I will skip it right now. The visualization of watermark could help you to understanding the data latency situation for every stage in your pipeline and the end-to-end latency exactly. For example, you would see the dips or spikes of your input watermark and check with your upstream what's happening at that time. Also for job recover, how you make sure you could get complete data from that time. And even you could combine with Kafka consumer lag latent metrics for checkpoint tuning. Then how about large state tuning? Originally, we have our own Flink cluster for POC and evaluation. Then we use RuxDB and Hadoop as state backend. You would see how incremental checkpoint saving in HDFS. Then we switch to E-based streaming platform, which leverages RuxDB and Ceph as state backend, and found the checkpoint performance was better. That's also because the eBay Hadoop is a very big shared cluster. Sometimes they have very heavy jobs running at that moment, so our checkpoint may be delayed. We have some large jobs. Back pressure is not enough when job is catching up, since Flink doesn't consider checkpoint metrics as one indicator for the back pressure sampling. Especially the early, I'm not sure right now, currently Flink supports that for help that customer or user could specify what kind of metrics could be sampled by the Flink receiver. Especially in the earlier version of Flink has not integrated with Kubernetes resource management by calling API server directly, and the port loss, then checkpointing fail. The next checkpointing will get worse. Actually, we afford not efforts for those kind of stuff. So either we reduce the total size of job state, or reduce the state for each task, or improve the throughput for the checkpointing. Shorten is helpful for catching up when far behind with the currently processing time. We could refresh rate limiter when log append time far behind the process time adaptively. Different window type and length will definitely affect the state size. You may not have multiple sliding window, but use a fixed window for foreground feature and leverage feature selection to get them easily. This also improves the shareability of the feature. We should see in intermediate feature. Incremental combiner and stateful processing are very useful compared with group all elements for one-time aggregation and help for the job state or not. So our users should leverage them more. And we also need to enhance, we also have plan to enhance and leverage those more. A more parallel running task would help the throughput for checkpointing. You could say the bad one is 600 tasks and the good one has 1018 tasks with certain control and above method applied. Finally, we come to batch features. We want to have Flink runner for streaming feature and the Spark runner for batch feature. Then we could unify all pipelines with Apache Beam. Then we noticed the Beam capability matrix of Spark is not covering all we want at that time. Since we have tons of different data models between online and offline, we can't leverage the same pipeline codes for batch process anyway. And also, I don't get a chance to evaluate the DAG optimization in Apache Beam. It may or may not impact the Spark own DAG optimization. I'm sure it should not, but we still need to evaluate it, like push-down filtering, cost-based optimization, even adaptive execution, because etc. Because those optimization will change the query logic plan during runtime. So if you have your DAG management, I'm not sure, yeah. And more important to adaptive with executing Spark codes, and more important is to adaptively with its existing Spark codes easily and improve the shareability for similar batch feature generation process. I did an abstraction with the pipeline pattern at the beginning, and I haven't expected it's so close to Beam's abstraction later. We have a plan to merge our streaming SDK with batch SDK in future. Then we could have a chance to leverage Spark runner at that time, and trying to run previous batches in a streaming way. So how it looks like, several hundreds feature set have already been published by Airflow scheduling in eBay marketing. and have a reachable feature catalog for scientists to search and check. Actually, this feature portal does not only contains our batch feature, but also streaming. That's why you will see they have some duration to identify its daily basis or its like a 5 minutes window or 1 hour window. Since our team also take care of model serving in eBay, we have planned to help scientists to pick the correct feature for the validation of the when model deployment. So this portal helps them a lot. And we have many use cases right now, like inventory relevancy mapping, hotness items, core view signals, user reaction, etc. And I believe we could have a reachable ecosystem upon Apache Beam. And we will continue to enrich our feature serving layer because the eBay infrastructure and the platforms are highly rely on Java stack before. So we are still in the stage of providing our Python SDK, especially for integration with several components. It's definitely required in notebook, especially for combining with the TensorFlow extension. And we want to apply machine learning algorithm to push more calculation from model serving team to streaming team. Surely we want to leverage the latest Beam and Flink for reachable functions and better stability. If we could integrate with the data lake, it definitely will save our efforts for promise exactly once in Hadoop and reduce the complexity for file compaction and partition alter. We are investing new data store in eBay for our feature store. With more reachable annotation, like for define your custom coder or define or fine-grained control of your transformation, we want to leverage all of them to have a high degree and transparency for our transformations, state control, and monitoring. Yeah. So I will give a summary of today's talk. And first, we talk about the data model. Finally, we come to the consistent data flow for feature serving. And we talk about our feature SDK based on Apache Beam with the built-in function and the list structure support. And we talk about our feature and feature set structure, and also the integration with the kinds of components in eBay. And we also talk about a little bit about tuning and tracking for large state and watermark. So thank you all for joining this talk. Most parts are high-level introduction about what we are doing in recently 1 year with Apache Beam capability. And I hope it will give you more confidence for using Apache Beam. Thanks.
Thank you, Kobe, for your presentation. We have one question from our attendee, and the question says, how do you use Beam from notebook? Can a user run job with Spark or Flink from a notebook?
Yeah, this is a very good question. For Beam with a notebook, I think GitHub page already have corresponding notebook model to see each step for integrate Beam with notebook. It's very easy, and you could try step by step. And also, actually, we have we are working close with eBay AI team for the AI hub and integrate with the notebook. For Flink job, running Flink job and Spark job from notebook, I think there is no limitation or restriction. It's the same like you run from your pack your jar and upload to cluster for running them. The only thing is about the like I said, the resource. It's because if if your company like a streaming platform or Hadoop platform already or integrate with notebook, like say we could provide some SDK for your with your with corresponding resource, you could you could specify how many port you want from Kubernetes server and to run your job. Then it could be act as like a job driver side or job client side to send your job to the cluster. It's how your infrastructure team integrate their resource platform resource management with the notebook. Yeah, but in notebook, I think for you much more easily is like you can run your local runner with a Beam for some functional part test, and then you could say you want a specific port, like a KF serving. You can specify how many memory and CPU used for your model serving. Same thing. Yeah. Actually for the SQL part, this is a very interesting topic. That's why, and today I emphasize we are not use purely SQL for on Beam for Spark and Flink. First, I should say when Blink merged with Flink, right? I'm not sure you are how familiar you are how familiar of Flink SQL you used before, and actually if you compare with Beam SQL and Flink SQL, I think Flink right now Flink SQL maybe have more reachable functions provided based on their latest version. But anyway, if you want to use the SQL to run this, actually our streaming platform already provide the SQL to our customer, but it still require customer to write codes for custom watermark and some UDF. That's why, like I said, if you I haven't show it in our example. You will see from the P collection. Actually, you can dot select. You can dot other method. You also can P collection dot SQL to say select some columns from that P collection. So we would rather to provide a mixed way, like when you use Spark data frame, right? You have multiple functions and you have a corresponding query. Then you could use them as a mixed way instead of limited on the pure SQL. Yeah. So in eBay, actually they largely invested on Flink SQL for streaming ETL processing.
Okay, I think that were the two questions. Okay, there's another question. Our use case is train model from notebook using Spark and then use Flink for runtime. Are you guys using this way?
No, it's a little bit weird, but I should say because our scientists are familiar with Spark, because Spark have many like good data frame batch processing support and the machine learning library, and they may have generated some data. If I should say, if you use Flink for runtime, I guess here is for streaming feature, right? It's for generate do some aggregation for streaming feature. You could do it like us, like publish that feature to runtime and offline both. Then scientists can combine that data with in Spark for their training, or even upload back for serving as well. And the most if we distinguish the runtime, process team, and batch, usually we talk about runtime about the model serving. So because sometimes even scientists get the feature from the batch side or streaming side, they still need to do some pre-processing for model serving. So we need to have some container based. if you check with fast or keep serving or Kubeflow, and we need to we also investigate those kind of stuff, yeah, for model serving part, yeah, in our team.
Okay, I think those were all questions that were asked. Some attendees requested your LinkedIn profile. If you're comfortable enough, please share. If not, it's okay. And thank you all for attending. I hope this webinar was useful, and thank you, Kobe, for a great presentation. I hope you submit your talk for Beam Summit that is coming soon, and I think more people can benefit from learning what you do at DB. Okay, everyone, have a great day or evening or night, depending where you are, and thank you for attending, and see you next week. Actually, next week we're going to have presenters from Google. They will talk exactly about how Beam is used for building machine learning pipelines like Beam and TFX. So that should be interesting, and see you next week. Bye.
Bye.